Greetings and hello all. This is Miss Jackson. I'm going to make a video covering the extra practice that I'm going to be sending home tomorrow, January 9th. This is going to cover, the bulk of it's going to be 2-digit by 1-digit multiplication. I have another video posted that goes over the 3 multiplication methods or strategies that we have learned to solve 2-digit by 1-digit multiplication problems. They are the area model, partial products method or model, and the standard algorithm. You can refer back to that video if you want to see those more in depth. This is going to help us apply those strategies to word problems for the most part. I will say I'm going to use each strategy to solve, like area model I'll use to solve 4, 5 will be partial products, and 6 I'll use the standard algorithm. Before we get into that though, let's do a review on problems 1, 2, and 3, which is division. 36 divided by 6. That means we have 36 total things. We can't have more than that because this is a division problem and 36 is our total. We're taking those 36 things and we are going to divide them into 6 equal groups. 36 is a fairly manageable number that we can use the equal group strategy to solve. So there's really 2 ways that I would look at solving this. Honestly, there are a whole lot of ways to solve this division problem. I'm just going to show you 2 ways today. Step 1 is, or strategy 1, way 1, the first method, let's go with that, is going to be to make that delete. Oh, hey, there we go. Is to draw 6 groups, because this tells me we're putting 36 things into 6 groups. And I'm going to try to draw them a little bigger than I had it. 1, 2, 3, 4. Ooh, there we go. That's 1, 2, 3, 4, 5, 6 groups. That's perfect. And from there, we're going to go through and put a dot in each group evenly until we get to 36. And once we get to 36, we'll look and see how many dots are in each group. 35, 36. There is 36 total things divided out into 6 groups. When I look into one group, I see that there are 6 dots in each group. So 36 divided by 6 is 6. If you take 36 pumpkins and you put them into 6 wheelbarrows evenly, there will be 6 pumpkins in each wheelbarrow. That's one way to solve this problem, and some of the kids really like that, and it works when our total is smaller. The problem with this method is if we have a great big number that we're trying to divide out, like 81 divided by 9 equals something, 81 dots, that's a lot. That's a lot of dots, friends. And that is 81 chances to make a mistake. So when we start hitting those big numbers, I really don't like the dots in groups method. And let me erase that and show you what I would use instead. Going back to problem 1, 36 divided by 6. Another way we can solve this is to flip this division sentence into multiplication. So we had 36 divided by 6 equals blank. We're going to have blank times 6 equals 36. We need to figure out how many times do we need the number 6 to get to our total of 36. And the kids love to skip count, and they're really good at it. They are super skip counters. So let's try that here. We're going to skip count by 6 until we get to 36. 6, 12, 18, 24, 30, 36. Now it took me 1, 2, 3, 4, 5, 6 times of counting 6 to get to 36. And my answer here would be 6. Let's do this again, and let's do it with problem 3. And I like problem 3 because problem 1, when you turn that into multiplication, it ends up being what's known as a square fact because it's 6 times 6. And if you drew that into an array, you would have the same number of rows and columns. Or if you drew an area model, same number of rows and columns. It would be perfectly square fact. Let's look at that solving number 3 because it is not a square fact. And I'm going to erase this previous work. so I have room. 32 divided by 8 equals something. So we can take it, we can draw 8 groups. We just have to be careful and make sure we have all 8 of them there. We can go through and we can put our dots very cleanly and neatly. If you're a third grade friend watching this, and once we get to 32, we're going to count our dots. Well, if we take 32 dots and we put them into 8 groups, I'm going to have 4 dots in each group. If these were Oreos and we were sharing them with 8 friends, each friend would get 4 cookies. The next way to solve this is to flip division into multiplication, because we have learned that division and multiplication are inverse operations. They're opposites of each other. You can create fact families with them. So I would take this and it would have been blank times 8 equals 32. So I need to figure out how many times do I need an 8 to get to 32, and we can skip count that. 8, 16, 24, 32. 8 4 times gives me a total of 32. And so my answer is 4. Okay, let's move down to problems 4, 5, and 6, because 1 through 3 was really a review of something we've learned, but division is so tricky. And so it's always good to review that. But 4, 5, and 6 is what we're really here for. Problem 4 says, Remy spent 14 days at the beach last month. She picked up 9 seashells each day. How many seashells did she collect in all? So we need to set up our number sentence first. Well, she was there for 14 days, and every single day she picked up 9 shells. So this is a multiplication problem. 14 times 9. To solve this one, I'm going to solve it with the area model. To use the area model, and so many of the third grade friends tend to like the area model and do pretty good with it. If they make a mistake, it's a small calculation mistake. It's not from not understanding what they're doing here. We take 14 and we decompose it into the expanded form, which is the tens and the ones in this case. We have a 10 and we have 4 ones. We're going to add that to this happy little box. That's going to keep us organized. And this 9, the other factor, needs to come along this side. From there, we can multiply 9 times 10. That's the first thing we're going to do. 9 times 10, that's pretty simple, 90. And then we're going to multiply 9 times 4. And 9 times 4 is 36. To finish this, we need to add together what these two, what they call partial products. 90 plus 36 is going to be 126. So she picked up 126 seashells in all. And let me just use these color pens to show you what we just did on this area model, on this original number sentence that we wrote. We did 9 times 10. That's multiplying the 9 times this 1 in the number. This 1 is not a 1, it's a 10. After that, we multiplied the 9 by the ones place. Oh, I wish that was different. It's different now. The 9 times 4. 9 times 4 is 36. From there, we put together our 2 different products that we got from breaking this problem down, and it came to a total of 126. Okay, let's look at problem 5. Problem 5 says, maybe, Danielle shipped 34 bags of oranges to a grocery store. Each bag weighed 8 pounds. How many pounds of oranges did Daniel ship total? Let's see. We're going to use the partial products method to solve this. So we have 34 times 8. We know there are 34 bags. Each bag is 8 pounds. I would not encourage the kids to draw 34 circles and put 8 dots in each one and then add those dots together or anything like that, because there are too many chances to make a mistake. So here we are. We're going to use multiplication and simplify our lives a little bit. Step 1 for this is going to be to break down our 2-digit number into expanded form again. 30 plus 4. We need to multiply all of that 34 in this case 30 plus 4, by the second factor, which is 8. Oh, that's terrible, 8. Okay. From there, we're going to start solving the problem. We're going to work in the ones place first. 4 times 8 is 32. And you can even make a note out here where that came from. That is from this 8 times 4. Next, we're going to multiply together 8 times the 3 in the problem, which is really a 30. 8 times 30. 8 times 30 is 240. And you can make a little note out here where that came from. From there, we just need to add again these partial products together. And our total is 272 pounds. That's how many pounds of oranges Daniel shipped. Okay, the last problem that we're going to work out is problem 6. And for problem 6, and let me erase this right here, we're going to use the standard algorithm. This is the way that most of the adults learned to solve multiplication problems way back in the day, before cell phones and great and wonderful things like that. We learned the standard algorithm. So this says Bailey collects baseball cards. He has 46 pages of baseball cards in his collector's album. Each page holds 6 cards. How many baseball cards does he have in all? So our number sentence to solve this is going to be 46 times 6. I'm not going to draw 46 groups and put 6 dots in each one, because again, that's too many chances. There are way too many chances to make a mistake. So I'm going to use on this one the standard algorithm. We're going to stack it. It looks kind of a lot like the addition standard algorithm. We need to make sure we line up our ones, our tens. When you get older and you move on to big and great things, you're going to make sure your hundreds and your thousands are lined up, and all of that is perfectly in line, just like on the standard algorithm for addition and subtraction. Same thing for multiplication. Line your stuff up. Okay, we're going to start in the ones place, just like when we just did partial products. We're going to start with 6 times 6. 6 times 6 is 36. I am not going to come write 36 here, however. What I'm going to write is the 6, and I'm going to carry the 3 above the tens place. Just like in addition, when we regroup and move things into the correct place, we're doing that here also. So that 3 needs to go above the tens place. From there, I'm going to multiply 6 times 4. 6 times 4 is 24. And then we need to add our 3 that we had regrouped up here. 6 times 4 is 24, 25, 26, 27. So the answer is 276 cards. If he has 46 pages of baseball cards and each page has 6 cards, then he's going to have 276 cards total. The bottom is just comparing two numbers using these comparison symbols, and we have really worked on those. And if we go slow and we are really paying attention to place value, then we're going to be okay. So we'll just do one of these together. 56,319, 56,199. Both of these numbers have a 5 in the 10,000s place, and that doesn't help me because they're equal. They both have a 6 in the thousands place. Still doesn't help me because 6,000 and 6,000 that's the same number. They're equal. We're going to look in the hundredths place next. Oh, I see one has a 3, one has a 1. 3 is greater than 1, so we're going to use the comparison symbol that has the bigger side over there towards the bigger number. You'll do that on all the rest of the problems at the bottom. And that will conclude day 7. I think I'm going to make a totally different video for day 8 because day 7, it went on for a minute. That's okay though. Day 8 will be uploaded next, although technically in the stream of things, it will look first, like it's up there first. But this is day 7. The next thing we're going to work on is day 8 in a whole new video. Thank you for watching. If you have any questions, please reach out and let me know, and I will try to help you the best that I can. Thank you.